I want to light up this LED. The only power source I have is a 9-volt battery. Unfortunately, maximum voltage this LED can handle is around 3 volts. So if I connect the 3-volt LED directly to the 9-volt battery, it will get damaged. To solve this, we can use a resistor in series with the LED. The resistor will limit current and safely light up the LED. Now the question is, what resistor value should be used to safely light up the LED? For that, we use Kirchhoff's voltage law. Well, in this video, let's discuss about Kirchhoff's voltage law. In my Kirchhoff's current law video, I told you that in a circuit, if there is a junction, the total current entering the junction will be equal to the total current leaving the junction. But in case of voltage in a circuit, total power supply voltage equals total load voltage in a closed loop. And this is Kirchhoff's voltage law. Here, closed loop means any closed path in a circuit. For example, in this particular circuit, there are 3 loops. This loop, this, and this. These are all in a closed loop. In a closed loop, total power supply voltage means the sum of voltages across power supplies, and total load voltage means the sum of voltages across loads present in the loop. Power supplies can be a battery, a generator, etc. And load can be an LED, a resistor, etc. All these loads have resistance. Okay, let's come back to our problem, the LED circuit. Goal here is to find the value of resistor. Let's apply Kirchhoff's voltage law. Let the total power supply voltage be V1, voltage across the LED be V2, and voltage across the resistor be V3. Applying KVL, we get V1 equals V2 plus V3. Here V1 equals 9 volts because we have 9-volt battery, and we want V2 to be 3 volts because LED maximum voltage is 3 volts. So V1 equals 9 and V2 equals 3. Now let's solve for V3. Here, if we apply Ohm's law in the resistor, V3 will be equal to current I in the circuit times resistance of the resistor R. So voltage across the resistor is I times R. The specification of the LED we are using says that current flows 0.03 amps when 3 volt is applied to the LED. Therefore, current in the circuit must be 0.03 amps. So V1 equals 9 volts, V2 equals 3 volts, and V3 equals 0.03 times R in the circuit. Now just simplify the equation and we will get the value of the resistor. We get 200 ohms. If I make the same circuit practically, the LED glows without getting damaged. I already made a video on this LED circuit, link is in the description. The procedure of actual Kirchhoff's voltage law is a little different, but results are the same. Kirchhoff's voltage law states that the algebraic sum of potential differences or voltages around any closed loop is 0. To apply Kirchhoff's voltage law in a closed loop, voltage across each of these components should be taken first. Taking voltage is a little tricky. You should note that voltage across the power supply can be either positive or negative. If total power supply voltage is taken positive, then voltage across all the load components in the loop should be taken negative, and vice versa. This is because when voltage across all load components are taken negative, and separating out from the KVL equation, it will simply mean total power supply voltage equals total load voltage. So results will always be the same. Okay, not to get confused, firstly show polarities in each of these components. In the resistor, wire connected to the positive side of power supply is positive and wire connected to negative side is negative. So these are the polarities of each of these components. Now we can take voltages in the closed loop in clockwise or in anti-clockwise direction. Let's take clockwise direction in this loop. To make sure not to take voltages of a component more than once, take a point in the loop. From that point, start taking voltages and finish in that point. So in this loop, from this point, the first component is the power supply. Since we are taking voltages in clockwise direction, voltage polarity of the power supply goes from negative to positive. If this happens, simply take voltage across the component positive. Now let's take voltage in the second component, that is the resistor. Voltage polarity of the resistor goes from positive to negative because we are taking voltage in clockwise direction. So if it goes from positive to negative, simply take voltage across the component negative. Similarly, in the third component, the resistor, it goes from positive to negative, so take voltage across it negative. As you can see, using this procedure, nothing will be wrong. If power supply voltage is taken positive, load component voltage will always be negative. Okay, now you can apply Kirchhoff's voltage law in the loop. Add all the voltages found in the loop and it should be equal to 0. If you rearrange the equation, you can find that the total power supply voltage equals total load component voltage. In this circuit, find current if resistance is given 10 ohms. First of all, show polarity of the resistor. The power supply looks pretty strange. In this loop, two power supplies are connected in this configuration. Since one power supply has more voltage than the other, polarity of the load components should be taken from that highest voltage power supply. So polarity of the resistor is this. Now take voltage in clockwise or in anti-clockwise direction. I am taking voltage in clockwise direction. So from this point, first component voltage is positive V1, second component voltage is minus V2, and third component voltage is minus V3, suppose. Applying Kirchhoff's voltage law and simplifying a little bit, we get 3 minus V3 equals 0. Now apply Ohm's law in the resistor. V3 equals I times R. Here R is given 10 ohms. So V3 equals I times 10. Substitute the value of V3 in the KVL equation and simplify. So current in the circuit is 0.3 amps.